The Plinko Probability Simulation is an interactive educational tool designed to help students understand the fundamental principles of probability. This simulation allows students to guess which bin a ball will fall into, compare multiple trials, switch between concrete and abstract representations, and explore binary probability. By providing a visual and hands-on approach, the simulation enhances students' understanding of probability and its applications. The Plinko Probability Simulation focuses on the principles of probability, which is the study of the likelihood of different outcomes. It illustrates how random events, such as the path of a ball falling through a series of pegs, can be modeled and predicted using probability theory. The simulation includes various tools and visual aids to help students explore these concepts in depth. The simulation features a Plinko board, which is a vertical board with a series of pegs arranged in a triangular pattern. Balls are dropped from the top of the board and fall through the pegs, bouncing off them in a random path until they land in one of the bins at the bottom. The bins at the bottom of the Plinko board collect the balls. Each bin represents a possible outcome, and the number of balls in each bin indicates the frequency of that outcome. Students can guess which bin a ball will fall into before dropping it. This allows them to test their predictions and observe the actual outcomes. The simulation allows students to perform multiple trials by dropping multiple balls and observing the distribution of outcomes. This helps students understand the concept of probability distributions and the law of large numbers. The simulation further allows students to switch between concrete and abstract representations of the Plinko board. The concrete representation shows the physical board with pegs and bins, while the abstract representation shows a simplified diagram of the board with arrows indicating the possible paths of the balls. The simulation introduces the concept of binary probability, where each peg represents a binary decision point. The path of the ball through the pegs can be modeled as a series of binary decisions, leading to a deeper exploration of binary probability. The simulation also features a quinkings board, which is a specific type of Plinko board used to illustrate the binomial distribution. The quinkings board has a symmetrical arrangement of pegs, and the balls follow a binomial distribution as they fall through the pegs. The Plinko Probability Simulation provides a hands-on approach to exploring the principles of probability. By guessing which bin a ball will fall into, performing multiple trials, switching between concrete and abstract representations, and exploring binary probability, students can understand few key concepts. The probability of a ball falling into a particular bin is determined by the number of paths leading to that bin. Students can observe how the distribution of outcomes changes as they perform multiple trials and collect data on the frequency of each outcome. The law of large numbers states that as the number of trials increases, the observed frequency of each outcome approaches the theoretical probability. Students can observe this principle in action by performing multiple trials and comparing the observed frequencies to the theoretical probabilities. The path of a ball through the pegs can be modeled as a series of binary decisions left or right. Each peg represents a decision point, and the path of the ball can be represented as a binary sequence. This allows students to explore the concept of binary probability and understand how it relates to the distribution of outcomes. The quinkings board illustrates the binomial distribution, which is a discrete probability distribution that describes the number of successes in a fixed number of independent Bernoulli trials. Students can observe how the distribution of outcomes on the quinkings board follows a binomial distribution and understand the relationship between the number of trials and the shape of the distribution. Switching between concrete and abstract representations of the Plinko board allows students to understand the underlying principles of probability in different contexts. The concrete representation provides a visual and tangible representation of the board, while the abstract representation helps students focus on the mathematical principles of probability. The Plinko Probability Simulation offers several educational benefits. The simulation provides an interactive and engaging way to learn about the principles of probability. Students can actively participate in the learning process by guessing the bin, performing multiple trials, and exploring the concepts of binary probability and the binomial distribution. Probability can be an abstract and difficult concept to understand. The simulation provides a visual and tangible representation of probability, making it more accessible and understandable. Students can experiment with different numbers of trials and observe the resulting distribution of outcomes. This exploratory approach encourages critical thinking and problem-solving skills. The simulation provides a practical application of the principles of probability, which are fundamental to many real-world phenomena, such as the behavior of random events, the design of experiments, and the analysis of data. This helps students see the relevance of probability in everyday life. To implement the simulation in the classroom, teachers can follow these steps. Begin with a brief introduction to the concepts of probability, the law of large numbers, binary probability, and the binomial distribution. Provide examples to illustrate these concepts and explain how the simulation will help students understand them. Demonstrate the simulation to the class, showing how to guess the bin, perform multiple trials, switch between concrete and abstract representations, and explore the concepts of binary probability and the binomial distribution. Explain the importance of observing the distribution of outcomes and how it relates to the principles of probability. Allow students to explore the simulation in small groups or individually. Encourage them to experiment with different numbers of trials and observe the resulting distribution of outcomes. Provide worksheets or prompts to guide their exploration and data collection. After collecting data, have students analyze the relationship between the number of trials and the observed frequencies. They can use the principles of probability to interpret the data and draw conclusions. Facilitate a class discussion to share and compare findings. Encourage students to reflect on what they have learned about probability, binary probability, and the binomial distribution. Ask them to consider how these concepts apply to other areas of mathematics and everyday life. The Plinko Probability Simulation is a valuable educational tool that brings the principles of probability to life through an interactive and engaging context. By allowing students to guess which bin a ball will fall into, compare multiple trials, switch between concrete and abstract representations, and explore binary probability, the simulation provides a hands-on learning experience that enhances understanding of these fundamental concepts. This interactive approach not only makes learning more enjoyable, but also fosters critical thinking, problem-solving skills, and a deeper appreciation for the relevance of probability in the real world.